Hey everybody, Tinnell here. We got some rocks that we collected from the Quartette mine yesterday when we were out there, and what we're going to do is we're going to show you the method of small scale method that I have installed here by my house, a crusher and a recovery equipment, and we're going to crush it up and show you what we get out of it. Alright, we got our crusher here. I'm getting ready to start it up. We're going to crush the rocks. That's step one. Alright, that was a miniature version of what we've got out at the mine to use to go on a much larger scale to crush. And as you can see, it's kind of dusty. The neighbors probably don't like it too much, but as an example, it works very well. And then we're going to get on to the next step. Alright, we're going to take the ore that we just crushed. We're going to put it through this screen. So we got to have it really small for it to work on the table. And then we'll be on to the next step. We got the stuff that we crushed from before. Now we're going to stick in this other small crusher. It takes it down to pretty fine powder. This is what it works. Just dump it in here. Alright, we got the crusher going. Now I'm going to turn it off and I'll show you how much it crushes it. Face powder. Okay, what we do next is we dump this all together, and then we're going to put it up there in that feeder up here. And it's going to feed out onto this Wilfley table, which is a 1/20th scale, but it's an exact reproduction replica, only smaller, of the table that we use out at the mine in our recovery equipment. So it's a good approximation of the actual way that we recover the gold. Alright, we're running out of daylight a little bit, so we're going to pick this up in the morning. Good morning. Well, we're out here at the Quartette mine, and in the old days back in 1995 when we were originally here, we had rehabbed the underground workings down to the 125-foot level with this structure. But we don't have to go underground anymore, and it's much less dangerous to just get the ore right on the surface. Yeah, we're over here now almost 1,500 feet away from where we originally started. And it just goes to show you that this immense vein just goes on, and it goes all the way past here and up over this next hill. So the amount of ore that we have is quite substantial. Alright, we're here with some of our equipment. We've got our grader, motor grader in the background in case we have to grade some roads. And this is our Komatsu 35-ton PC300 excavator that we dig the ore with. Alright, we're here standing in what was actually my idea to install this $100,000 induction furnace in a portable moving trailer. This is our portable furnace trailer, and this is what we do with the concentrate after we make it through the entire process. This is what smelts it down, and we're going to get a closer look at what's going on. This is our Ajax magnethermic induction furnace. This is our test furnace. We usually like to do a 2-pound melt so we can make sure we get the flux right. After we get the flux right, we go ahead and transition to the larger melt. We do our big production melts in here, and remember that this is a type of furnace that has absolutely no flame. It's an electromagnetic coil that's cooled by water, just like a nuclear reactor. Now we're going to go over here and look at the power supply for the induction furnace. Yeah, this is the power supply for the induction furnace. It's a pretty sophisticated piece of equipment that delivers the DC voltage necessary to melt at 3,000 degrees. Yeah, this is the furnace select side of the induction furnace. Open it up, let you see the SCRs, that's the power supply. And then, yeah, this is the hydraulic actuator that actually dumps the induction furnace as soon as it's all melted, finished melting, and it's hydraulically lifted by those rams, and then it tilts down, and we pour it in those red mold size bar molds. Yeah, this is our 500 kilowatt generator that powers all of our equipment. That's what we use to power everything, in case you're wondering. This is our welder, and we get our 110 power from it. Yeah, we're here at the Quartette mine site where we've constructed our large-scale mill that does 240 tons per day capacity. This is our ball crusher mill, and it leads into the classifier, which makes sure that the material is the proper size. The classifier goes into the jig right here, which also segregates the parts according to their specific gravity. And then the hutch concentrate goes to the Wilfley table. The Wilfley table produces concentrate goes in the furnace. Hey, good morning. We're here with one of the final stages in the process. We've got our little miniature Wilfley table. Mark has laboriously hand-screened a goodly amount of the ore so that he can see it with his own eyes and verify for you guys that there is actually metal in this rock. Now, if you zoom in now, we're already starting to get a little bit of a line of silvery gold on the table. You can see it right there. The way the table works is the heavies are cycled to the end of the table and were collected, and the lights are washed off the end. Okay, we're watching the Wilfley table. It's going good now. The stratification of the specific minerals that we're looking for, the heavy ones, is occurring. The Wilfley's working good. You can see how the water is washing the lighter particles off, and the heavier particles are concentrated in this line right here. This line right at the top is going to be your little baby gold nuggets, and then they're going to be mixed with silver and other precious metals. But you can see that this thing really is very efficient at segregating the little particles according to their specific gravity. And this is a small-scale version of the actual method that we use at the mine. It's just much, much bigger. We're here with the concentrates that we made with the Wilfley table. What we did was dry them in the sun. Now they're nice and dry, and now we're going to take them to the independent analytical lab to be analyzed for their gold content. Alright, we're here at the analytical lab, Jet Silver Ventures, and we're getting ready to process the concentrates that we made on our Wilfley table at home and also analyze the raw ore. What we're going to do is we're going to mix up some melts, and then we're going to make some little silver beads, which are analogous to the bars we make out at the mine, and then we're going to analytically determine the amount of gold that is in the bars and in the beads so that you guys can see if there's gold in this or not. Alright, we're here. I'm mixing up some granulated test lead that is silver free. It's had the silver removed from it. I'm going to weigh out 30 grams of test lead. We're going to use test lead and silver as a collector on the concentrates that we made, and we're going to see how much gold's in it analytically by using an XRF gun. Okay, in gold analysis, what you use is 1 assay ton. 1 assay ton is 30 grams. If you melt down 30 grams of a sample and you get 1 milligram out of it, that will be equivalent to if you melted down an entire ton and got 1 ounce out of it. So we're hoping for milligrams so we can determine how much gold is in this. When I do an assay, a scorification assay, I use 1/10 assay ton, which is 3 grams. We're actually doing an analysis on how much gold we can get out of 3 grams of the concentrate that we made. Alright, we're here at the electric furnace that's about 2,000 degrees, and we're getting ready to put the melts from the concentrate that we made. One's been roasted and one hasn't, and we're going to see how much gold is in it, and y'all are going to see it get melted, and we're going to put it in the furnace now. Okay, we're going to see what it looks like molten up close. Alright, the melt is finished. We're going to open it up and we're going to pour the molten metal down into these little conical molds right down here. Alright, we've got our melts out, we've got our lead buttons, we poured them in a conical mold, and now we've got them out, we've got the slag off of them, and we're getting ready to put them back in, and we're going to cook them down again, and we're going to be left with only a gold and silver bead in the bottom of the cupel. Okay, our melts are done and we're ready to pull the cupels out that have the silver beads in them. The melts took about an hour and cupellations took about 45 minutes, but you can clearly see the gold, the silvery button in the bottom from both of them. Alright, now if you zoom in, you might be able to see another phenomenon that's called sprouting, and it has to do with differential temperatures of solidification in the metals that are inherent in the little buttons that we just made. Okay, we've got our little silver beads now, and what I'm going to do is I'm going to mash them flat, and then we're going to take them inside and we're going to let the XRF gun do a analytical shot of all the metals that are inside these little silver buttons that we use to collect all the precious metals. So we just take them, put them on a piece of metal, and then you just pound them flat. Just like that. That's number one. We take the other one, just like that. Just like that. Okay, we've just taken one of the beads and we put it inside the $60,000 analytical gun that actually sends a little bit of radiation out and excites the atoms to see what wavelengths they are, and it determines up to 50 metals.
Yeah, it is.
Is it still on? Okay. Zoom in on the AU.
Steady still.
Okay, the computer's making its determination, and all of these printouts are going to be available for your review, so that Mark will have all the results. Okay, we're back here from the lab with the results from our analytical testing, and we're going to review it. So the only thing you're going to see from now on is my hands in the video. Okay, we're here with the results. Basically, the first result is on the powdered ore that Mark crushed up. The results from the powdered ore, and remember that we took this from the very best part of the vein, and the results from the middle of the vein were 150 parts per million, and that's in mining mode, and mining mode is designed in the XRF gun to be an overview of like raw ore and to show up to 50 elements of analysis. The result of 150 parts per million can be converted to ounces per ton by dividing by 32 parts per million. So this result would indicate that there are as much as 4.6 ounces of gold per ton of rock from right in the middle of the vein, which is very significant. When we run the regular ore, we're shooting for 1/10 or 2/10, but the fact that we can pull something out of the side of the mountain with Mark watching me, the rocks themselves, he picked the ones out right out of the vein, and get a result of over 4 ounces per ton in the raw ore is extremely significant. Similarly, the other mode that the XRF gun is able to detect is when you have the precious metals inside of a metal bar or a metal button, as we made. The goal of our analysis was to see if we could get some of the gold in the sample into the silver button, because this is exactly analogous with the way that we do our recovery out at the mine. We take our concentrates, we concentrate them many times to make them as low a volume as possible, and then we melt them into silver bars. And then the silver bars are analyzed by an XRF gun to determine the gold content. When we analyzed our small button that we made in the video, the result was 973 parts per million in the button, which is analogous to being in the bar. So what that means is you divide 973 by 32 and you come up with a little bit over 30. So inside our bars, we would have the equivalent of 30 ounces in a ton of bars. Now that is a very good result for a one-pass concentrate of 10-to-1. When we do it at the mine, we do many more concentration steps, so we end up with a much more concentrated version. But the fact that we can reach a parts per million in this silver button of 973 with only one pass is extremely significant. Alright, this is a test that I performed last February to determine 3 separate spots of where we're going to mine at the Quartette. We took 3 20-pound samples, which is exactly 1/100th of a ton. And from each 20-pound sample, we made a concentrate, and then we recovered all the gold out of that 20 pounds, and we refined it down to purity. And what our results were is we got 0.053 grams of actual pure gold out of 20 pounds. We got 0.047 grams of pure gold, and we got 0.109 grams of pure gold out of just 20 pounds. So what that means, I know it's a little hard to see, but that little bit of pure gold, you can actually extrapolate from that and multiply by 100 to see what you're going to get out of an actual ton of gold. And these are actual recoveries, and then we take an average of that, and that's what we shoot for. The results of these tests are that we averaged 7 grams per ton of recovery, which is very substantial. Then we did an additional test where we did 500 pounds at once, and the 500 pounds was recovered in the same manner. We made a concentrate, we got all of the gold out of it, and the amount of gold we were able to get out of 500 pounds is, it's a lot easier to see this, is 2.5 grams. And 2.5 grams out of 500 pounds puts us right on track for a recovery of 10 grams per ton. So this way it gives y'all an idea of being able to see exactly some pure gold that I refined down to purity that I got out of a 500-pound batch test. We're going to be running 10 tons per hour and 240 tons per day. So if you extrapolate how much gold I got out of 500 pounds to 240 tons, you can imagine that we're going to be turning out a good amount of ounces.